solve. Now for number E here, we have 3 equaling 2x plus 1 and 7 equaling x minus 2. Now for this problem, we can use any log we choose here to work with this problem because the bases are different here. So we don't even have to pick a log of the same base. Essentially, we want to use that power rule. So to do this, I'm just going to pick ln. You could pick just log base 10 or just use log of whatever, but I'm going to use ln. So this is going to be the ln of 3 to the 2x plus 1. And then you'll see what I mean by this. They don't always have to be the inverses when I want to get to the power. So this is going to be ln of 7, and then this is going to be x minus 2. So now the power rule says that I could take whatever the exponent is and pull it down in front of the log function. And that's what I'm going to do for both sides here. So this is going to be 2x minus 1 times the ln of 3. And that's going to equal x minus 2 times the ln of 7. So you can see how I got to that variable. At least I got that variable down out of the exponent so I can actually deal with it here. Now I'm going to have to distribute these ln of 3 and ln of 3 on the left side through. Now keep in mind, just ln of 3 is just a number, so don't panic and think it's something strange. So I get 2 ln of 3 of x. And I can just do this just so you know that that's all just some decimal number there. Again, like I said, don't get bogged down with the notation. And this is minus ln of 3. And that equals x ln of 7 minus 2 ln of 7. And then from here, I can get my x's on the same side. And honestly, this right here, this minus, I'll deal with that later. But I'm going to move this x. So I'm going to subtract x ln of 7 and subtract x ln of 7. And now keep in mind, these are the same terms because they're both x's. And I'm going to add ln of 3 to both sides because I want to get rid of this over here. So I'm going to add ln of 3. So I'm going to get on the left side now 2 ln of 3 of x minus ln of 7 x, and that's going to equal ln of 3 minus 2 ln of 7. Oh, that looks terrible. So now then on the right side, I can say that this is ln of 3. And I'm not going to skip a step here just because I know this is still fairly new. Ln of 7 squared. And then that's going to equal ln of 3. Oh, let me fix it, 3. Over 49. Because this minus here, when I minus, it ends up on the bottom. So all of this here will equal ln of 3 over 49. And then on the left here, I can pull an x out of those two. So I really have 2 ln of 3 minus ln of 7 x. And all of this I can actually put together too in a very similar way. So that 2 I can bring to the power. Oops. And that would be ln of 3 squared minus ln of 7. So the ln of 3 is 9. So this is really the ln of 9 over 7 because that's a minus. It's a quotient rule. So that's what that turns out to be. And that equals the ln of 3 over 49. So now I'm going to divide by the ln of 9/7. And divide by the ln of 9/7. And we get x equals that answer there. And that's my final answer for this one. Now remember, just because I'm dividing here doesn't mean I'm going to, I can actually do a log property here. The log property isn't a quotient of the logs, it's an addition or subtraction of the logs. So this is as far as I can go with this one here. All right, let's look at the next one now. This one here is a little different than the last one here. This one is using the idea of factoring. The way I look at this, when I see this right away, this is x squared minus x minus 6 equals 0. This is what I see when I see this e to the 2x, because that e to the 2x is really e to the x squared. And that's why I look at it as an x squared here. So that's just something to think about. And when I actually run through this problem then, this is just a simple factoring problem. That's difficult to see because of the distraction of the e as the base. So this is really just going to be e to the x in one parenthesis and e to the x in the other, because when I multiply those, it's going to be e to the 2x because I add my exponents. And then this is going to be a minus 3 and a plus 2 equals 0. And again, it had to be a negative there because when I multiply that, that's going to be negative 3e to the x, and that's going to be positive 2e to the x. And when I add those, I'm going to get a negative. So that's why I need a negative on the larger number. And then the signs had to be different because it's negative there. So, and then it's 6, so 2 and 3. Okay, so that's how I actually factored that. So going back to the problem now, that tells me then that e to the x minus 3 equals 0, or e to the x plus 2 equals 0. So now I'm just going to run through and solve these. So first I move the 3 over. So e to the x equals 3. And then from here I have to ln both sides now because that's the inverse. I know, weird. You got to get used to that though. So the ln of 3 on this side. So x equals ln of 3. And that's one of my answers. And the other answer is subtract 2. So that's e to the x equals negative 2. And I will never get an answer for this, because once I try to ln, I don't know if you'll notice this or not, that's e to the x. And I try to ln negative 2. I can't ln negative 2. I can't take the ln of a negative number. Another way to look at this too, to know that you can't get anywhere with it, if I have e to the x, what's the smallest that can be? If I go towards negative infinity with my x, I can get close to 0 but never get 0, and definitely never be anything negative. So that doesn't give me an answer. So my only answer is x equals ln of 3. That's a nice problem to go through because you run across that scenario, which I think is important and can be somewhat confusing.